The nearest star to our planet is the Sun, which is about 150 million kilometers away. The time taken by the light to reach us from the surface of the Sun is about 8 minutes and 20 seconds. If the Sun disappeared right now, we wouldn't find out until the light stopped arriving. But what about gravity? The Sun were spontaneously removed from existence. How long would Earth remain in its elliptical orbit before flying off in a straight line? Believe it or not, the answer to this must be exactly the same amount of time as it was for light, 8 minutes and 20 seconds. The speed of gravity not only equals the speed of light to an incredibly precise degree observationally, but these two constants must be exactly equal theoretically, or general relativity would fall apart. Before general relativity come along, our most successful theory of gravity was Newton's universal law of gravitation. According to Newton, the gravitational force between any two objects in space defined by just four parameters: gravitational constant, mass of the first object which experiences the gravitational force, mass of the second object which attracts the first object, and the distance between two masses. You can perform all sort of calculations from these equations, like elliptical planetary orbits around the Sun. But the equation only works if the gravitational force is instantaneous. This might puzzle you a little bit, so hear it carefully. If you do calculations and allow Earth to be attracted to the Sun's past position rather than its current position, you get a prediction for its orbit. But the answer you get will be wrong, and the same answer was given to Newton during his observations as well, due to which he was also wrong. In fact, if you use Newton's laws to calculate the orbit of the planets and demanded that they match the modern observations, then the speed of gravity have to be 20 billion times faster than the speed of light. Let me explain you this more precisely. If you have a central force where a bound particle like the Earth is attracted to the Sun, which moves around the Sun at a finite speed, you will only get a purely elliptical orbit if that force's propagation speed is infinite. If it's finite, then you don't just get a radial acceleration towards the other mass, but you also get a component that accelerates your particle tangentially. This would make orbits not only elliptical but unstable. By 1805, Laplace had used observations of the Moon to demonstrate that the speed of a Newtonian gravity must be 7 million times greater than the speed of light. Modern observations are now 20 billion times the speed of light, which is great for Newton. But all of this placed a great burden on Einstein. According to Einstein, there is a big problem conceptually with Newton's gravitational force law. The distance between any two objects is not absolute. It depends on the motion of the observer. If you move towards or away from any object, the distance in the direction will contract depending on your relative velocities. Therefore, according to Einstein, you would have to develop a theory that brought gravitation and relativistic motion together, and that meant developing general relativity. As I have discussed earlier, that for a planet which moves with finite velocity, they get a radial acceleration as well as tangential acceleration that makes the elliptical orbit unstable. This tangential acceleration is induced by the finite velocity of the gravity, which is provided by the Sun, and it termed as gravitational aberration. To counter this problem, another opposing force must be introduced so that the elliptical path should be in balance. Thus, in general relativity, Einstein's equation has a velocity-dependent term which cancels this. Hence, from here it is considered that the opposing force must have a speed of light to cancel this speed of gravity. In 2017, we got a practical proof of this incident when the gravitational wave and a light from two colliding neutron stars reached to Earth. We observed that just after 1.7 seconds of the arrival of the light, gravitational waves reached us. So up to certain approximation we can say that the speed of gravity is equal to the speed of light. So guys, that's all for now. Hope you have liked this video. If not, then please like it. And if you think that my content is good, then please subscribe my channel. Otherwise, thank you for watching.